relativity. So for one reason or the other, it has been a few days since we had a lecture. So where we left off, if you recall, what is the first thing that I must discuss? In my energy momentum, when I defined the Maxwell field, there were a few units missing. It's an easy fix, but it's important that I fix it. What I wrote was the following. What I wrote was 0, Ex, Ey, Ez minus Ex minus Ey minus Ez. And then 0, this is anti-symmetric, minus By, diagonal terms are 0, minus Bz, Bx, By minus, and minus Bx. This is what I wrote. The actual value is not far away from it, just a missing unit of C. It should have been. So here's the correction. It's divided by C. And where I noticed this is, so I had defined this quantity. Now, this is with all these two indices lower, but then an anti-symmetric sum. And we simplified this a little bit, and then we got this expression. This is all in the way of recall d nu f lambda mu plus d lambda f mu. And the claim was this guy. This guy gave the homogeneous Maxwell's equations. What are the homogeneous Maxwell's equations? Divergence of B equal to 0, the ones with no sources, that's what I mean. And Faraday's law, right? But when I didn't put the original C, I got 1 over C, which is bad. But guess what? Now with this entered C, I would get E over C. And so very nicely, the C's would cancel. Okay? So you can indeed verify that this is the homogeneous Maxwell's equation. But we haven't encountered something like this before. As a matter of fact, we've been so focused on special relativity that we really haven't worked that much with derivatives. This is all in the way of recall. So, let me begin with a question. Any questions? No? Okay, so we're going to elevate or try to understand what this guy is. Hopefully my notes, I've been making small edits as we go along, inserting C's and whatnot. And numbers may have changed around. Like I said, when I finish this chapter, I'll have the updated notes. But what we have to show is the following. I think I called it, again, I called it theorem 3.5. These are just calculations. It's not like a math theorem, so to speak. But it's a good way for me to organize my thoughts instead of just words scattered about. Okay? We have to, everything, we mentioned that laws of physics should be invariant under Lorentz transformation. Everything has to be invariant, or there must be a nice transformation property. So if this is true, well, if this is true in one frame, we must show that this is true in every frame. Otherwise, why this whole big deal about relativity? We cannot fail at Maxwell's equations. Yeah? So that is precisely what this theorem is. And I think I stated it this way. Lambda is equal to, that's not true. Equal to 0 implies well, both ways. They're equivalent. So that means the result is independent of the Lorentz ring. If I show this, are we good?
Do we just take this for granted?
Sorry?
Are we taking this for granted?
Speak up.
Are we taking this for granted? In this case?
Are we taking this for granted? No. I have to prove it.
Oh,
Yeah, if it says theorem, I better have a proof.
yeah.
I thought you were just saying that too.
Yeah, I was like, oh, okay.
Well, we could.
Just write it down.
Yeah.
That's what we're hoping is true.
Here's let's make sure.
I mean, I believe it, so.
Yeah.
Physics by faith. Okay.
Yeah.
I like that.
I'm
I'm
like that.
So,
If you write something on the board, you're not going to believe it.
well, you need to make sure that, it holds up. I need to explain what this is. So this, the way I wrote it, what do you think that is?
D mu bar or dx.
dx bar u. That's what it is. Okay, in the new coordinate system. And how does it work? X bar mu is equal to lambda mu x nu. Okay. So I'm going to start with the left-hand side. D mu f nu lambda equal to, I'm going to write it with 3 terms. You won't like it, but, and tell me how we got this. Alpha mu lambda inverse beta nu lambda inverse gamma lambda f d alpha f, what is it? Beta. Yeah, that's what this is. Correct? Yeah. Well, is it?
The inverse only applies if it's.
That's not what this is.
Shouldn't it
Tell
be?
you what this is. I get 3 terms. Oh, of course, I erased what I needed the most. What is this? F mu lambda. What is that equal to? 1/3 d mu f mu lambda plus d mu f lambda mu plus d lambda f mu mu. Yeah, so I'm going to take this term and transform it, this term and transform it, and this term and transform it, and I should have a 1/3, which is missing from my notes, so I'm just going to do 3 times that. And the first term, which is d mu f mu lambda plus, and then what I'm going to do is keep, well, I'm going to change these indices. So I'm going to put lambda inverse, what's the mu, right? So I'm going to put alpha and then mu, lambda inverse, beta, then lambda, correct? And lambda inverse, gamma, and mu, and I'm going to put d alpha.
Yes, it shouldn't that
Oh,
be
yeah. Yeah. D alpha, beta, mu.
Wait, shouldn't.
What did it be, gamma? Gamma, beta, gamma, beta, gamma.
Yeah.
Alpha, beta, gamma. Good. There's so many indices. Beta, gamma. Plus one more term, correct? I'm going to write that and then I can erase this guy. Plus lambda inverse, let me do it this way. Lambda inverse, and then I have, what is that? 3 of these, lambda mu nu. See, I have new lambda mu, which is new lambda mu.
Should the indices not be?
Huh.
Oh no, never mind. I see.
Lambda, alpha, beta, gamma, lambda, mu, d, alpha, beta, gamma. Are we good so far? So this is what and this is actually rather convenient because I have the 3 terms over here. Now I'm going to stop. I'm going to call this guy 1 and 2, and I'm going to do a dummy variable change.
Question.
Huh.
Could this have been simplified by just putting? What? Could it have been simplified by putting parentheses next to the first transformations we have, and then just rotate the indices of like d alpha, f, beta, gamma, instead of rotating the transformations? Like, as we rotate the transformations every single time.
Yeah.
But could we not have just left the transformations the way they are, and then just change the indices on the actual tensor and the partial derivation? Because if we did that, it just wouldn't take us much space.
Well, so what I was doing is I was literally writing these 3 terms
Yeah.
and then transforming each of them.
Yeah, you start with the.
I see what's happening. I'm wondering if you could write it as in parentheses, like you do d alpha,
Well,
f beta gamma,
let-
and then
well-
d beta f gamma alpha.
It probably can, but what I was trying to be honest in mind, so 3 times bar, mu f bar, mu lambda, that's equal to d mu f nu lambda
Yeah.
plus two other terms, right? So then I transformed these and wrote it here. So I was, perhaps that was my intention.
Okay. I see.
Yeah, if there's a clever way, there could be a clever way.
I don't think it's clever. I think it's the exact same
Yeah.
thing. It's just
Yeah.
using parentheses.
Oh, you mean factor those three things out?
Yeah. Just.
Yeah, but
'cause-
that won't help us in the next step.
Okay. Okay.
Yeah, yeah. No, that's a good point, yeah. So I'm gonna, this term, the second term, I'm gonna call it 1, and the third term, I'm gonna call it 2. And then I'm going to write 1 with the change of dummy indices. So I'm going to say 1 is equal to, let me write it, and you tell me if it is kosher. Lambda inverse, I'll tell you what I've done. Or you tell me what I've done. Alpha, beta, nu, lambda inverse, gamma, lambda, d beta, f gamma alpha. What did I do?
You switched this summation.
So what I did was I wrote this guy, this mu, as the first one. So I brought mu over here. And in doing so, and I wanted all these things to be the same. So then I replaced gamma with alpha. When I replace gamma with alpha, this has to be alpha. So you see that? That became alpha. Little bit of a mess. And then I wanted the second one to be what? Nu, right? So what I did was I brought this and made it, yeah. So I brought mu first, and this had to be nu. And I left it as beta, so that doesn't change. What did I do? No, I replace.
You place beta in F in the tensor with
I want to
gamma.
make sure I replaced nu with mu. Am I correct?
Yeah.
If I replace nu with mu, then alpha has to be summed with.
Yeah. You've got it right because you've got beta nu over here.
Yeah.
So you've put beta. You put nu in.
Yeah.
Yeah.
So beta has come over here.
Yes.
Yeah. And the same thing I do with the second one,
Yeah.
so that I can make the terms align a little bit more. And what do you think I want in the second one? Again, I want mu nu alpha to be in this exact same sequence. Why are you smiling, Jackson?
This is exactly what I was asking you.
Oh,
Yeah.
right. But yes, right.
You end up having those three terms.
Yeah, but
without-
what I wanted to do was I wanted to individually start with the left-hand side and end up with the right-hand side. Yeah,
See.
very good. Lambda inverse alpha mu, and I think it's the same thing. Lambda inverse beta nu, lambda inverse gamma lambda, except now this becomes gamma f alpha beta. So then, what I'm going to do is 3 times f bar nu lambda is equal to, I'm going to keep this version here. And replace these two terms with these two terms. That is easy because I just copied anyone, I made all of them the same. And then I have d alpha f beta gamma plus d d beta f gamma alpha plus d gamma f alpha beta. Yeah, so Jackson, we wouldn't want to do it that way. The way you said, we wanted to start off with this side and then convert each.
Because, well, that's my final, what I had written down. This is what I had
Correct,
written down. But I
correct.
mean, I just-
And so
I
this
just didn't
is
do
nothing
this.
more than lambda inverse alpha to mu,
Yeah.
lambda inverse beta mu, lambda inverse gamma lambda, and then I have d mu, nope, d alpha, let me put a parentheses, alpha f beta gamma. So, but we know this is 0, right? So, this, when you multiply this with this, when you contract with all zeros, it's 0. So, if this is 0, this is 0. And they're just dummy indices, so it works both ways. It looks like a whole lot of huff and puff, but it is important to verify that these relations hold true regardless of the Lorentz frame.
Well, it's supposed to be 3 times it, isn't it?
I multiply by 3.
Or on the right-hand side, this is also.
Oh, right, so, right. So if we do it this way, very good.
Just put 3 in front of it.
3. Very good. Is that clear? So the homogeneous Maxwell's equations are covariant or Lorentz invariant, whatever you want. I don't know what the correct term is anymore. Just transforms nicely. Okay, now what about the inhomogeneous ones? What do they look like and how do they transfer? So these are a couple of homework problems. I would like for you to do them. I'm just going to list it out here and hopefully these are the numbers. I think these are the numbers. I wanted you to show that this is the Lorentz force. QE plus B cross B. Just put this out. So there'll be 4 equations, and you know there are 4 force equations. The 0th component is going to give you the power. We talked about this. And the spatial components will give you, it should end up with I should say U. The next one, 3.24, I would like to show for you to verify the inhomogeneous Maxwell's equations. d nu f mu nu is equal to mu 0 j mu. So when you put mu equals 0, you should get divergence of E equals rho over epsilon naught. When mu equals the spatial components, what must you get? Curl of B, that equation. Because we've done curl of E already. Because curl of B has a J in it. So it's also important to verify this. There are a couple of other problems that I have stated. It is important, but not for our conversation. Of course, for the exam, it might be important. But these two, I wanted to state what these problems are about. Okay, so now I want to talk about the energy momentum tensor. If you have taken E&M, you know what energy momentum tensor is. At least you've seen the spatial component of it. Here you can't have just spatial component. You have to have space and time component. So let me do this. Beginning, I'll talk about the energy momentum tensor of the electromagnetic field. And then I'll talk about energy momentum tensor in general. Like what are the properties of these guys? So if you recall, you've seen the expression for this in the E&M course, but if you haven't, that's okay. We'll verify, I'll state the result, and we'll verify what quality state it has. Does it have, does it lead to the conservation of energy and momentum? That'll be one of my most important concerns. So here's, I was trying to put on my sheet of paper and read my glasses. So this is not very enlightening as it looks. Very harmless. But look at just how tensors work. F mu alpha, F nu beta. This 1/4 looks odd. Lambda mu nu. We're done with indices, but it has to have two fields. So if F alpha beta, F alpha beta. That's what it is. At the moment, but here's why it is interesting. And I hope I can finish this. Again, it's not a big deal, but that it's a theorem. In vacuum, V mu P mu equals 0. So it is sort of like the 4 divergence is 0. 4-dimensional divergence. Look at that. Yeah? It's being summed over space and time. Only in vacuum. So what do I do? Well, d mu T mu equals 1 over mu 0. Tell me why I did this. Okay, I'm going to skip not the whole step that I planned on doing, but rather let me write down the other one. Minus 1/2 What is the unusual step I did? Let's focus. I've not done anything here. Eta is a constant. It doesn't see derivatives. But what is the one step I skipped? This guy's derivative. Why did I skip that? Oh, I didn't mean for it, but the answer is on the board.
Oh, is it?
It is
Yeah.
this, but it's vacuum. In vacuum, J is 0. So if I took the derivative of this guy, it would give me 0. Okay? So then I write equal to 1 over 2, 0. And did I lower? I did not lower, but I did. Let me tell you what I'm going to write. Alpha beta d alpha f nu beta. And now I'm just writing this term. Let's make sure that you agree with this. First of all, if alpha goes, mu becomes lowered and it becomes beta. Right? But then I lift beta up and I bring beta down here. Can I do that?
Why does the new go down?
Oh, right.
Yeah, why is mu going down?
Yeah. Good, very good. Sometimes, and very good. You guys, I lowered nu on that side. So the nu just got lowered. This beta came down, this beta went up. This alpha made mu beta, but since beta came down, it goes upstairs. Okay? Now, when I take the derivative of this, it's this and this will yield the same result. So I take the derivative of 1,
Same as
and yeah.
multiply by
So multiply by 2. So that becomes
minus 1 half.
minus 1 half, correct. And d nu f alpha beta, because I have,
Is it supposed to be d mu, or is that supposed to be d mu?
yeah, it is d mu, but look at this, it's mu nu.
Oh, so you.
The nu has been brought down.
Mu.
Yeah,
Mu
so-
is summed over and mu.
Yeah, there's so much tensor things going on. So what am I saying? D mu, and there's eta mu, well, nu first. Okay, so that itself becomes, well, d mu, nu, but then I lowered nu. So this becomes nu. When I write eta this way, this is the Kronecker delta. So that means this is non-zero only when mu is equal to
Mu.
nu. Are we good? We're only, using all the techniques we talked about. So if we're missing out any information, please let me know. So I'm going, are we good? So what I'm going to do is I'm going to rewrite this by change of dummy variables, and I think I put 2 steps in there. So that I can rewrite, so that is equal to, let me rewrite it, and you make sure that beta alpha beta mu alpha minus 1 half mu f beta alpha. What did I do here? Changed alpha and beta,
Revert, yeah,
right? Just swapped it. I can do that because they're just dummy indices being summed. I'm going to play one more trick. Let me write this is equal to minus f alpha beta. Why did I do that? I didn't need to write it as a separate line, but I did. So. Alpha beta. Yeah. Why did I do this? Oh, why could I? First of all,
Shouldn't read the negative sign.
F is anti-symmetric.
Yeah.
But they're- but
Yeah.
The inside.
Yeah, I didn't swap this.
Oh, you swapped them on the other side. I didn't see that.
No. Forget that. Yeah. So here I just copied this down and I replaced F beta alpha with F minus because it's anti-symmetric. Now, this is just because of this swap. But here, again, I swapped and I
So you get a negative
Yeah.
on the bottom.
So these are all equations, these equations are the same, but I'm just going to call this temporarily 1 and 2. And I'm going to add this 2 times. So I'm going to do 2 times d mu, t mu equals, well, I'm going to write it as f alpha beta over mu f nu beta minus f beta nu alpha minus d nu f alpha beta. So I added this, there's alpha nu beta, then there's this, but then I add that to this guy. So there's this minus that shows up over here, and these two are the same, but now because of this, they both have the minus sign. Yeah? Are we good? So very quickly, but recall, I have this to be true. F nu beta plus d nu f beta alpha plus d beta f alpha nu is equal to 0. But what I'm going to do, is I'm going to what do you think I get? I'm going to stick this in here, and then I get 2 times f alpha beta over 0 minus, everything is minus d nu f beta alpha plus d beta f alpha nu plus d nu f d nu beta d beta alpha nu d alpha f nu beta. Guess what? What would be my conclusion? What did I want to set out to show? It is 0. Now, why would it be 0?
Because that's just cyclical.
This is the homogeneous,
Yeah, it's homogeneous.
first homogeneous Maxwell's equation. Yeah? So, this is 0, then we have the result. Yeah? A lot of tensor manipulation today, huh? Just make sure you follow through and that you can justify every step. Now, in the exam, you're not necessarily doing these same, sort of calculations. It's been done for you. I just covered everything in detail. Yeah? But you should know what we did and why we did it.